Okay, so I just wanted to share just a quick video of this first one about the formal definition of an ellipse. So if you read through here on this page, it says an ellipse is a collection of all points in a plane whose sum of distances from two fixed points is a constant. And each of the points is a focus, and together they'd be called foci, plural. Okay, so a fixed point and a fixed point, and then any given distance. And so we're going to actually prove this a little bit of this formula in class tomorrow. But what I also wanted to do is just give you at least the relationship where we can find these foci algebraically. And so a fixed distance. So like I tried to show a screenshot here of if you were to measure this distance there, whatever that distance is, it's going to be fixed along this perimeter. So if I pick this point right here, measure that distance, the sum of those two pieces is fixed. If I pick this point, the sum of those two pieces is fixed. So as I slide this around, right, all the points here, if I measure the distances to each of the focal points, it's a fixed distance. Okay, so that's our definition. And so in terms of getting some measurements here, we already talked about the major axes, right? The major axes is the the distance of the line of symmetry that's the longest. In this case, it's a horizontal direction. So if this is my major axis, let's go red. So this is the major axis. Then I'm going to define half of that distance to be my A value. And we talked about that in our notes last week. So this distance right here, I'm going to call A, going from the center to either end of the major end of the axes, either end of the major axes. And then I'm going to call the value of B, in this case it's this direction, the distance from the center along the minor axes. And so there's a B and there's a B, A and an A. And then I'm going to introduce a variable C to talk about the distance from the center to wherever the focus is. So that's a value right there. And obviously you can have a C value over here as well. So this idea of C being the distance from the center to the focus, okay, there's a relationship that exists between A, B, and C. And in fact, it's the following Pythagorean theorem. So A squared A squared, which is the bigger distance, will equal B squared plus C squared. And again, we're going to prove this in class tomorrow. But an easier or a better or more useful, I think that's the adjective I'm looking for, a more useful version of this particular formula is actually solving for C squared, because that's often what you're looking for. You're looking for the focal length given given the other two distances. So if you solve that for C squared is equal to A squared minus B squared. So that's sort of the formula that I'd want you to know for finding the distance, finding the focal length given any ellipse. Now notice it's solved for C squared. So then when you do A squared minus B squared, don't forget to take the square root. The advantage of this particular formula is that both A squared and B squared appear in your equation. So if you have a standard equation, where you know where A squared and B squared is, and these are the next examples, you know exactly, you basically just will subtract the two to find the focal length. And again, here's that formula that we just looked at, and we'll prove in class tomorrow. So in terms of notes for this first part of the section, please make sure you know what the definition of A is. A is half the length of the major axes from center to the end. B is half of the minor axes from center to end. And C is the focal distance. The relationship that exists, C squared is A squared minus B squared.